Here we go. By simply pressing these two buttons, you can switch the light to different color filters. As for these top and bottom buttons, they control the power. In this episode, our restoration master will repair this Swedish railway signal lamp from the 1950s. Opening the cover reveals a lot of grayish-white residue around the nickel-iron battery, which is dried electrolyte. Potassium hydroxide reacted with carbon dioxide in the air to form these potassium carbonate crystals. Aside from the filter system, this liquid battery is arguably the most fascinating part of the lamp. It is hard to believe this 70-year-old battery is still perfectly functional today. That white residue has not caused any irreversible damage. It is just a minor issue from aging and environmental exposure. Its incredible longevity comes down to the fact that liquid batteries are fundamentally different from standard ones. In these batteries, the electrolyte is not consumed in reactions. It merely serves as a conductive medium. The nickel and iron electrodes are not depleted during charge cycles. They simply switch back and forth between chemical states. This means it stores and releases energy through state transitions rather than consuming its own materials. So even decades later, as long as the core structure is intact, it works fine after a good cleaning. Now that the main disassembly is done, he will start by treating the outer shell and its remaining paint. After a quick clean, he sprays a testing reagent that reacts with lead to fluoresce under UV light. The obvious glow confirms lead paint, meaning he must apply paint stripper before sandblasting. Old paints contained lead because it significantly boosted corrosion resistance and color vibrancy. Since lead is highly toxic, removing it now prevents harmful lead dust from going airborne during sandblasting. For the upcoming sandblasting, take a wild guess at what abrasive he will use. Props if you get it right. Before revealing the answer, sandblasting simply uses high-pressure air to blast abrasives, physically stripping rust-off parts. This physical impact leaves microscopic pits on the surface, creating a distinct matte texture. Different abrasive materials and sizes yield different finishes, and here he is using brown aluminum oxide. After blasting, beneath this bare metal finish, we can see severe rust at the base and even some broken welds. He hammers the separated sections back into alignment before securely welding them in place. Using a simple soldering technique, he applies flux and melts solder with an iron to hold it firmly. With structural issues sorted, he fills the numerous rust pits on the surface using body filler. Once the filler cures completely, he sands it smooth to create a perfect base for powder coating. Next, he applies a coat of white powder primer to the parts. He then sands the primer layer, which smooths the surface, improves top coat adhesion, and enhances the final finish. For the top coat, he selects a deep blue powder. Moving on to the lampshade and internal brackets, he takes them apart for sandblasting. As we can see, these parts were originally plated, meaning they will need a fresh electroplating treatment later. Before plating, careful polishing is required because electroplating bonds much better to ultra-smooth surfaces than paint does. Seeing this green solution, it is clear he is setting up a nickel electroplating bath. While waiting on the plating, he polishes the mounting screws and applies a cold bluing treatment for protection. He can now begin assembling all these restored components onto the blue main housing. Luckily, the glass lens is completely intact and only needs a quick cleaning. Next up are the lamp bracket and filter switching mechanism, which he carefully disassembles. You might have noticed by now that remarkably, all the fragile parts like the glass lens, color filters, and even the bulb are unbroken. Even crazier, this vintage Philips light bulb still works and lights up perfectly. The only casualty seems to be this insulating backplate, which is cracked and unusable. Once dismantled, these metal parts go through the same sandblasting, polishing, and nickel plating process as the lampshade. The only difference is that this shade is made of brass. To replace the broken insulator, he machines a new one out of a phenolic resin sheet, commonly known as Bakelite. After tracing the design, he mills the 5mm board down to 4mm before cutting out the shape and drilling the mounting holes. With everything prepped, he reassembles the lamp bracket and filter switch, then installs them into the main housing. By the way, the bracket holds a spare bulb, and once installed, you can see exactly how the circuit connects. Once the filter assembly is in place, you can see how it operates. Unlike the power switch, its locking mechanism is located on the handle. Now, simply slotting these two assembled parts into the base is a breeze. Next up is restoring that incredibly durable liquid battery. While full disassembly is not needed, this diagram shows its inner workings. He just flushes out the old electrolyte and refills it with a fresh 20% potassium hydroxide solution. He trickles a 300 milliamp charge for 24 hours to wake up the dormant chemistry, then pushes 1 amp for 12 hours to fully optimize the electrodes. While it charges, he tackles the final component, the main handle housing all the switches, starting with a complete teardown. This sliding switch is used to lock the color filters in place. The grimy cotton handle wrap is actually soaked in varnish or resin, providing excellent grip, durability, and waterproofing. After disassembly, he sandblasts and powder coats the cover plate, just as shown here. These switch button sleeves were ruined during a rough removal, so he machines brand new ones from scratch. The power switch button caps also need to be custom made. He finished the buttons with a protective nickel plating before installing them onto the cover plate. Next up is the sandblasted cast aluminum handle body, which gets a thorough smoothing and a high gloss polish. He then wraps a fresh cotton cord around the grip, though he skips the varnish coating this time. All the remaining metal pieces, like the filter switch and lock, receive a uniform nickel plating. Now he can reassemble all these beautifully restored components to complete the handle. As for the fully charged battery, its voltage has jumped from a dead 0.3 volts up to a healthy 2.7 volts. With every piece restored to perfection, the final assembly brings this 1950s Swedish railway signal lamp completely back to life. Let us take a look at the stunning before and after transformation. On a scale of 1 to 10, how would you rate this restoration? Besides switching filters and flashing lights, railway workers also used specific motions to signal different messages. That wraps up today's restoration video. Thank you all for watching. Time flies when you are having fun, so it is time to say goodbye. Thanks again for visiting Max's Restoration Zone. See ya!